Okay, today we're going to be looking at tangents and normals to circles. It's the second part of the chapter on circles. We looked at equations of circles, and if you remember, a tangent is a line that touches the edge of the circle. What a normal is actually perpendicular to the tangent. And since tangents and a radius meet at 90 degrees, a normal will actually go through the centre of the circle and through the point that we're after, and will be perpendicular to the tangent. So as the line goes from the centre through the point that we're after, like that, the tangent will always be perpendicular to that one. So we're basically looking at a line that goes through the centre and the point on the circle. So for example, if I've got the equation of a circle like this, I want the equation of the normal that goes through minus 1, 8. The first thing I need to do is find the coordinates of the centre. So a bit of completing the square, x minus 2 all squared minus 4 for that one, plus y minus 3 all squared minus 9 equals 21. I don't think I need the radius, but I do like to be completist. So with the 21, sorry, the 9 across to make 30, the 4 across to make 34, r is root 34. What I am after though is the gradient of the line from the centre, 0.23, read off from there now, and the point minus 1, 8. So it's probably worth doing a little sketch. Minus 1, 8 is up there, and 2, 3 is down there. And our line goes like this. So I want the line that goes through either of these 2 points. Minus 1, 8, 2, 3. So minus 1 to 2 has gone 3 along. 8 down to 3 is 5 down. So m equals minus 5 over 3. My equation then is y equals minus 5x over 3 plus c at, right, I'm going to use minus 1, 8, but I'll check it with the centre. I'll say why in a minute. So 8 is 5 over 3 plus c. C is 24 minus 5, 19 over 3. So y equals minus 5x over 3 plus 19 over 3, or any equivalent one to that. I've found from experience when there's 2 points to choose, we can choose the centre or the point in the question. If it's a tangent, the tangent must go through the point in the question and not through the centre. I hate to say it, made the mistake of actually putting the wrong, when I asked for the equation of a tangent, I've actually put the coordinates of the centre of the circle in, quite recently to be honest. So I think I'm going to get in the habit of telling you lot to always use the point on the edge of the circle for the tangent and the normal. I can check it, 2, 3 satisfies it. So when x is 2, I've got minus 10 plus 19, 9 over 3, which is 3, so that's good. A couple more examples then. To do the tangent in exactly the same way. They've already given me this, so I can read off the centre as 5 comma minus 2, and I want 9, 0, so 5 minus 2 is down there, 9, 0 is up here, so that's my normal there, and I want the tangent through 9, 0, I want that line there. So from minus 2 up to 0 is 2 up, and from 5 to 9 is 4 along, so the gradient of the normal, changing y with changing x, 2 over 4 is at half, the gradient of the tangent then is minus 2. So y equals minus 2x plus c at 9, 0, 0 equals minus 18 plus c, c equals 18, so y will equal 18 minus 2x is an equation of the tangent. I can see there, and I haven't drawn the circle. I don't tend to draw many circles. The sheet I do with this is actually given a better version of example 3, but it's there, so I'm going to use the drawing in this particular case. But a lot of it is Pythagoras and right angle triangles. So in this case, example 3 says we've got an equation of a circle, x minus 10 all squared plus y minus 3 all squared equals 121. And it wants the tangents that have got 0 gradients. So it wants these lines here. 0 gradients are the ones that are horizontal. So they are y equals. So I want the y value there and the y value down here. So the y value for the centre, 10, 3, is just 10 along and 3 up, so it's a y value of 3. The radius is root 121, which is 11. So all that first dotted line is a y value of 3 plus r. So y equals 3 plus 11, which is 14. And y equals 3 minus 11, which is minus 8. What's that? If I wanted, for example, the ones with infinite gradient, the vertical lines, I'd do the same for the x's. I'd start with the 10 and add plus 11 to get 21, x equals 21, and add minus 11 to get x is minus 1. That's all there is to that. Last example's got quite a bit more to it. It wants, here's an equation of a circle, so we've got a centre minus 3, 4, radius of 5, and I'm after the tangent and normal to the point minus 3, 9. Now because it's minus 3, 9, that's firstly above here, so what it actually is that point there, so I know that the tangent is a nice, bit like the one before, horizontal line, and the normal, the one to go to the centre, is a nice vertical line. So the tangent, let's call it t, is just going to be the y value, and since the r is 5 and that y value is 4, is simply y equals 9 for that one. And since this line here goes through that one, it's simply x equals minus 3. So dot dot, x equals minus 3. And they are just the coordinates of where they meet is the point minus 3, 9 on the circle there. A bit more to do for the last two parts though. I want the normal through the point P. P is the point on the circle where we have where it crosses the y-axis. So on the y-axis, x is 0. So I can solve it, sticking 0 in, 3 squared, 9, plus y minus 4 all squared equals 25. So 25 minus 9 is 16, y minus 4 is plus or minus root 16, plus or minus 4, so y equals 0 or 8. So at P, y equals 8. So I know it's at that point there. I can do my right angle triangle now and say that I've gone along 3 and up 4. So my gradient m is the change in y up 4. So I've got the change in x 3, and so the equation is simply y equals 4x over 3 plus 8 because it goes through the y-axis at 8, and that's my intercept. So that's an equation of the normal through the centre and through that point there. I can check it by sticking in x is minus 3 and getting y is 4, because it works as well. And it wants the area of this lot here, part C. So I could do with finding that point where the normal crosses the horizontal line. Well, the horizontal line is 1, y equals 9. So I'm basically solving 9 equals 4x over 3 plus 8. 4x over 3 equals 1, x equals 3 quarters. So I've now got a triangle like this, where I now know the total part there, because from minus 3 to the y-axis was 3, and this little bit there is 3 quarters, so that's 3 and 3 quarters, or 15 over 4, and the height of it is my radius, 5. So the area is a half times 5 times 15 over 4, which is 5 times 15, 75, 4 times 2 over 8 square units. And there we go, that's all there is to that.